This is Numbers with Nicole with a lesson on midpoint. In this lesson, we'll be going backwards. We'll be given the midpoint and an endpoint of a segment, and we're going to find the other endpoint. Okay, so if we're given a graph, we can do this graphically, and then I'm also going to show you how to do this using the equation. You can do it in either way. There's also another way we can do this, but I'm not going to dive into that here. So we have a segment RP, and M will be in the middle of that. We know that a midpoint divides a segment into two equal parts or two equal distances. So the distance of R to point M should be the same distance from M to point P. Okay, so M is the midpoint, and if we look at our graph, we know that the horizontal distance from R to M is 2. So if our point P is going to be the same distance away to point M, then we know that that horizontal distance is going to be 2. We know that the vertical distance between R and M is 3. So we know that the vertical distance, since everything is the distance from R to that midpoint will be the same as P to that midpoint, should also be 3. So you might say, aren't we doing slope here? Well, these values don't represent a rate of change. They represent the distance. They represent the lengths of the right triangles that form the distance from R to M. And we know that that right triangle should be the same to make the distance from M to P the same. So we get 3, 1 for our, right? 0, 1, 2, 3, 0, 3, 1 for our P value. So that's how we can do it graphically. We draw those right triangles, and we know that those right triangles should be identical to have two hypotenuses, two lengths, RM and MP, to be equal. Right? So we're taking that and we're using the graph to do that. We're applying our distance formula or our Pythagorean theorem, not slope. Okay, this is not slope here. Okay, so now what if we're going to use the formula? So we know that our formula for midpoint is x1 plus x2 divided by 2, so the average of the x's, and we know we would add y1 plus y2 and divide that by 2 and take the average of the y's. And so we know that the midpoint, what those x values will equal when averaged together, will be m, which is 1. So we know that negative 1 plus whatever the x of point P is divided by 2 should give us the x coordinate of the midpoint, which is 1. We know that the opposite of dividing by 2 is multiplying by 2, or because both of these sides of this coordinate in the formula are divided by 2, we know to undo that we will always be multiplying by 2. So the process for solving this equation here will always be the same for x and for y if we are given the midpoint. So we will have negative 1 plus x equals 2 times 1, which is 2. All right, well, what number plus a negative 1 gives me 2, or you can use algebra and we get that x equals 3, just like we did with the graphical method. So we're going to repeat the same steps, but we're going to do y this time. So we know that the 7, the end coordinate of R, 7 plus whatever the y coordinate of P is, divided by 2 should give us the y from the midpoint, which is 4. Again, to solve this, to get rid of that division by 2, we would multiply both sides by 2. So 7 plus y equals 2 times 4, which is 8. Well, 7 plus 1 gives me 8. And notice we have the same coordinates as we did above. P is a point, 3, 1. And that is the other endpoint of my segment here. So I'm going to do another example. This time we're not given a graph, so I'm going to go through using the equation again. So if you want to pause the video here, try this question out, hit play when you're ready, and see if you get it correct. You can always look up graph paper if you're interested in using the graphical method. However, again, you might not always be provided with graph papers. So if the midpoint of PR, so I'm going to just draw a segment to visualize this here. PR has an endpoint of 1, 6, and we don't know what R is. That's what we're looking for. And we know that the midpoint, Q, has coordinates of 7, 2. So you could think of this in terms of a number line also. That's another way to think about this. So if we think about just our X values, right? So my X distance from 1 to the midpoint is plus 6 units. So I know that to go from the midpoint to R, because these distances should be the same, I should be applying that same distance. And now if I think about my Y values, I'm going from 6 to 2. Well, that is minus 4 in the Y. Whee. And so I know to go from my midpoint to R, I should be applying that same change of minus 4, that same distance of 4 units away. We just have to make sure our direction is right. That's what the negative is telling you. It's not negative 4 units, it's down 4 units. So we know that 2 minus 4 is negative 2. So let's see if we get these same results by manipulating our midpoint formula. So x1 plus x2 over 2, y1 plus y2 over 2, and that would equal the coordinates of our midpoint. So let's look at our x's. So we know 1 plus x over 2 should give us a value of 7. We know that we'll multiply both sides by 2, which is the opposite of dividing by 2, and that gives us 14. So what number do we add 1 to get 14? That would be an x value of 13. So let's look at the y values. I currently have 6. I would average that with the y value from R divided by 2, and that should give me 2. All right, again, we're going to multiply both sides by 2, opposite of division by 2. So I know that 6 plus some number should give me 4. Well, to get from 6 to 4, I would have to subtract 2. And again, if we write this as a coordinate, that would be 13 comma negative 2 for that other endpoint, R.